Hello and welcome back to my channel. I will be talking about my deep learning based vehicle damage detection and cost estimation. This is a part two of my initial video. And my initial video, we discussed five different models that I trained. One of them was the YOLO family. Is three of them: the YOLO V5, YOLO V11, and YOLO V8. All these three models, I trained them, and I trained them different types of techniques. But for now, I'll just share the one that I found great success at. And my training was. When I trained them, I used AWS instances and EC2, AWS EC2, and that EC2 I once the training completed, I downloaded that notebook and uploaded it to Google Drive, and then I ran it in Google Colab. So for the training part of my video, it's a bit static. I wouldn't be running it. It's just I'll just show my results and. There are some minor mistakes that's due to me installing the notebook, and I think there was an error. I will talk about that. And once we complete that, then we will talk. I'll show you the demo. So let's get started. So my initial configuration was I've trained on 50 epochs with batch size of 16, image size of 640, and of course, I trained it on GPU, and also my early stopping is 5 epochs patience. Now, 5 epochs patience just mean that there is no changes in my MAP score for 5 epochs. If there's no changes, then the early stoppings will be triggered. Now, initially, my config. Now I start off with just importing the libraries for Torch Vision. I import others as well, Matplotlib and everything, and I define my hardware, which is L4. But then I also define my configuration, and this is just 640 with device. This is just a simple configuration for my AWS instance. And as you notice that I increased it because I ran it in another notebook, and it was too slow. So I started this notebook, and this new notebook is I used a more powerful instance where it had four NVIDIA L4 GPUs, and I ran it on 120 epochs with 128 for per batch. The batch size per GPU was per GPU is 128, so in total was 512, and 640 for the image size, that's standard, and my patience was 5 for both of my models, and for two of my models, and yeah, see is my configuration L4 across all four L4s, and here's my configuration with the batch size and my workers, and yeah. So when I started training my YOLO V5, it did train, it saved it, but for some reason this notebook preserved the error code. Yeah, so when I downloaded it, saved that, and I didn't want to spin up and rerun the whole training for that terminal output. So we'll just take it. I just used the device which had multi GPU and all the trainings, and the training started and it was running, but it was about to start, but then I got this error. This was I rectified it, but for some reason it did not save. So let's move on to the next model. For YOLO V8, it's the same setup configuration. All these are just defined it, and I made it dynamic. So I just called the values, and then I started the training. And as we recall, I trained it for 120 epochs, but I early stopping triggered around here, around 55 epochs. Training stop, early stopping as no improvement observed in 5 epochs. Best result of 50 saved at best PT, which is the model, by touch. And yeah, so it took about 50, 40 minutes. And yeah, so it stopped at 555 epochs, with the best performing one is 0.6063, which is 63%. But however, when I ran it on my data set, my test data, it performed at 61. That's saved in another notebook. Now, for your Myola 11, all I did was extend the training patients to 15. Initially, I did put 5, and I noticed that its performance was somewhat relatively similar. And when I observed, YOLO Ultralytics does provide diagrams and charts. So when I observed that, I noticed that it's more. The graph just goes up and down. It's not stable. So from noticing that, I noticed that it requires more training. It's still able to learn. So I increased the patience. I didn't adjust the learning rate, but I just increased the patience. And by increasing the patience, it ran further, as I noticed that it gets stuck at the local minima, so I didn't want it to get stuck there. So after I increased the learning rate, it achieved uh, somewhat significant results. This is 69% MAP, and after testing it on the test data set, it achieved the numbers I discussed previously, which is close to there, close to 66, 68, but 69, but it's around 66. Okay, so this is here. I'm just printing out the training summary of the models here. And as you can see here, I trade different types of models with different configuration, and the best was the one I kept. And then the results here is just models. And next, for my Gradio, I did do evaluation. It's just for the sake of saving time, I will not discuss it for this video, as I would like to direct your attention to my demo. So for this, as I mentioned, I will be using Google Colab. So I just import the libraries initially, and once I imported the libraries, then I bring the models, and I configure their parts. As you can see here, the model parts are configured and mountains loaded successfully, and I'm using Google Colab. So let's discuss the cost. So my part cost is for here. I tested with different annotations and stuff, but the ones that I settled with is this, which takes scratch, dent, damage, crash. Across different classes of the damage. As you can see here, the model has crack, crash, dent, dislocated part, glass shatter, a lamp broken, no part, rub, and scratch, and tire flat. All these are 10 classes. Previously, I did mention that I trained it across 11 classes. Now, the thing is, 11 classes worked well. The 11th class was uh, the 11th class was the background, but it performed well. Sorry, the background was involved when training the MobileNet V2 and FRCNN, as they both needed the background class. And but when I trained YOLO, it didn't really need it, so I just took it out. So therefore, it's 10 classes. It showed the same results. I just took it out just for training speed. And now, moving on to the cost, back to cost, is I just define a very static pricing, as this is the initial idea. The later on would be web scraping or other for my future improvements. And the labor would be the labor prices would be based on the regions. This is for native to Malaysia, so it's Kuala Lumpur, Selangor, Penang, and Johor. Kuala Lumpur and Selangor is what I did my studies on. I went around and asked a few workshops, and they told me some cases, and they showed me some cases and prices for their damage prices and their cost, and from there I divided it into three different categories, and I adjusted it based on the severity: minor, moderate, and severe. Now the and then For these different states, but then for Penang and Johor, I just adjusted it based on the price on Google. I just Googled the quotations and different locations. So for the labors, for the hours, I just did a standard predefined, which is the damage for crash is 8 hours, for collision, for scratch, for yeah. So moving on to my severity. For my severity, it's measured based on the confidence, because in my idea is that if the damage is obvious, so the model is able to detect it and it's obvious, then that means it's somewhat severe, and the confidence is higher. So when the confidence is higher, it counts it as severe. So the severity, it just starts with minor is less than 60, and moderate is higher confidence, and severe is anything above 80. So the calculation is quite straightforward. I set a default price, and then I multiply it by the labor cost. Is basically the hours times by the labor rate, and then I do the adjusted part cost, which is the part cost times by the confidence, as I spoke of, and then I total everything by plussing the adjusted part plus the labor cost, and then the subtotal, and then multiply it by the tax rate. And then subtotal, sorry, the tax is the subtotal multiplied by the tax rate, and then the total is the subtotal plus tax. So further on is this is just returning the class names and the confidence and so on, just to display it in the front end. And for my demo, once I've completed that, I just call the cost estimator function, and I defined it here again. No, this is just to show the cost report in Gradio. And then here is the Gradio interface itself and then once I define the Gradio interface, then here is I'll just launch it just to have a look at the demo. Now, once we launch it here, as you can see, the demo is quite simple. It's just a way for us to interact with the model. And this is what I showed to the insurance agents, and they played around with it. They used it for around a week, and they gave me some feedback, and will be applying it in my next projects in the future. So regarding so I would start off with dropping an image. I have here a Honda City here. Now, once I enter the Honda City, there, as you can see, it's the dislocated part, it's the bumper fell, and then dislocated part, it's the hood, and then it also identified that it's also dented, and the lamp is broken. And also it's so glass shatter, it's over here, there's something shattered here, so therefore it's shattered. And from here it identified the items, it listed down, and then once it lists down everything, and then it does the calculation, and the calculation is 5115. Now when I showed these kind of images to the insurance adjusters, they showed me their output, and their output is normally about 20% disparity, or 20 to 30% disparity. But as I mentioned before, this is due to the class. My classes are somewhat limited in my data set, and in the future perhaps I will add more classes and re-annotate the data set. That's about it for my demo. Thank you so much, and I hope to see you next time. Cheers.